So the first section is just introducing the Cartesian coordinate system and how to plot points. What the second section is looking at the actual function relationship. We're only dealing with linear functions in this section. So a linear function is just basically a straight line. And it has various values of slope. It can be a horizontal line which has a slope of 0. It can have a vertical line which has an undefined slope. It can have a slope that rises from left to right, which is a positive slope. It can have a negative slope, which is where it drops from left to right. So you can just plot the points to really you only need 2 points. If it's a linear equation, you only need 2 points to be able to draw a straight line. You can also generate more points and get a more accurate drawing the problem with 2 points is just getting the slope exactly right. But if you have 3 points, you've got a much more accurate representation. And typically what we do is you'd make a table. The book shows them as pairs, but what I'm going to do is I'm going to show as a pair. So I'm going to start with problem number 1. And what they have is this equation, which says 2x plus y equals 5. So this is in standard form for a linear equation. It's not the one we usually use. But what we'll do is we will create a table. And we have 4 points. So I'm going to make it a 5 by 2 table. And what we're given is given either the x or y, so you have to figure out what the x value is if you're given y and the y value if you're given x. So here's x and here's y. So the first one is we're given the x coordinate, but we have to figure out what the y coordinate is. The second case, we're given the y coordinate. We need to fix the x coordinate. We're given x equals 1. We need to figure out what the corresponding y is. And the last case, we have y equals 1. We have to figure out x. So the original equation is in 2 variables, but if we substitute in x, the resulting equation is just going to be in 1 variable. And we know how to do that. So if we start with our equation, and then we plug in the value of either x or y that we know, we get that. So that's the first part. X equals 0. So what is the y value? So all you have to do is you just have to simplify. So we multiply that out. You get 2 times 0 is 0. And really we can just drop the 0 at that point, and you get y equals 5. So we can fill in this. This is the corresponding y value with this relationship. Okay, for the second one, we plug in y equals 0. So we put 0 in for y. We can just drop the drop the 0, because if you have 0, you can just eliminate it from the equation. So now we've solved for the variable. Then you divide both sides by the coefficient. You get x is equal to, 2 divided by 2 is 1, so we've solved for x. You get x is 5 halves. Let me do a different color. So that's 5 halves. The next one is let x equal 1. So we do 2 times 1 plus y is equal to 5. 2 times 1 is 2. We want to solve for the variable, so we're going to subtract 2 from both sides. 2 minus 2 is 0. Just drop that. Y plus nothing is just y. 5 plus negative 2 is 3. So our corresponding y value here is 3. And then finally, the last one is we let y equal 1. So we plug in for y equals 1. So we get 2x plus y, but y is 1, equals 5. We subtract 1 from both sides to isolate the variable term. 2x plus 0 is 2x. 1 minus 1 is 0. 5 minus 1 is 4. Divide both sides by 2. 2 divided by 2 is 1. You get x equals 2. Okay, so write that down, 2. Now, if I take those 4 points and I plot them, we should get a nice, should get a graph where they look like they're in a line. So I'm going to do that. So here's my graph paper. This is the y-axis, this is the x-axis. So let's plot these 4 points. So you have x equals 0, y equals 5, so that's that point. You have x equals 5 halves, so that's 1, 2, 5 halves is 2.5, so that's 2.5, y is 0, so that's the second point we have. Now, theoretically, you could try to draw a line between those 2 points. So let's just do that for right now, and it will take me a few iterations here to do this exactly. Okay, so that looks like it's about right. But it may not be quite perfect. So if we do these other 2 points, 1, 3, so 1, 3 is right there, and 2, 1 is right there. So now we have 4 points, and that actually looks pretty good. This might just move a little bit because it's hard to know exactly where a half is. So those are the 4 points. We really only needed 2 points to draw a line. These extra values just give us a more accurate look at the whole thing. Okay, so let's do 4 now. So our equation is x plus 3y is equal to 12. We have again 4 points that we're trying to find. We're given x and y. Right, we'll give them one or the other. So same kind of deal. This is going to be x, the x coordinate. It's going to be the y coordinate. So if we look at 4, the first one is we're given x equals 0. We need to figure out what y is. We're given y equals 0 to figure out what x is. The third point, we're given 3. We need to figure out y. And then we're given 6. We need to figure out x. So those are the things we need to fill in. So again, we start with our equation, and then we just plug in whatever these are. So we have 2 variables here, but if I plug in x equals 0, plug in 0 for x, I'll get that. I can just drop the 0. I can divide both sides by 3. Solve for x. I get 12 over 3 is 4. So that's the y coordinate. Corresponds to the x value. Okay, so that was when x equals 0. So the corresponding value is y equals 4, y equals 0. So then we plug 0 in for y. So 3 times 0 is 0. We can drop the 0, and we get x equals 12. So when x equals 12, y equals 0. Okay, next we go next one, x equals 3. So we put, for x, we put in 3. We need to isolate the variable. So we need to get that constant here and somehow get it on the other side. And you do that by subtracting 3. 3 minus 3 is 0. 12 minus 3 is 9. Divide both sides by 3. 3 divided by 3 is 1. So you get y is equal to 3. So 3, x is 3, y equals 3. And then finally, the last one is y equals 6. So we go to our original equation. For y, we put in 6. 3 times 6 is 18. solve for the variable, so we're going to subtract 18 from both sides. 18 minus 18 is 0, so we just have x left over. 12 minus 18 is negative 6, so we get negative 6. So these are our 4 points again. I'm going to extrapolate to this one because it's kind of off the graph, but I don't want to use a different scale on my graph, so I'm going to put my graph paper in here. I'm going to plot a couple of points here, and they all should line up in a straight line. So, and again, this is x, this is y. We're assuming each one is 1 unit, so I'm just going to put the units out here. So this goes to positive 10, this goes to negative 10. Okay, so the first one's pretty easy. X equals 0, y equals 4. So that's right here. 1, 2, 3, 4. Okay, the second one is x equals 12, which is actually going to be right over here somewhere. Y equals 0, so that's the second point. X equals 3, 1, 2, 3, y equals 3. Just going to put the point right there, which makes sense because it has to be somewhere between those. And negative 6, comma 6. So we go negative 6, 1, 2, 3, 4, 5, 6, negative 6, 1, 2, 3, 4, 5, 6, positive 6. And now we have 4 points. We don't need all those points, but and you can see that last, I estimated where that was, but I can move that over here and put it exactly right there. So this is point negative 6, comma 6. This is point 0, comma 4. This is point 3, comma 3. And this last one is point 12, comma 0. Okay, we're going to skip over 7. It's basically what we've just been doing, so I'm not going to do that one. Now we're going to move on to this next large section. It says for each equation, give the x-intercept and y-intercept, and then graph the equation. And you can go back to these 2 examples here, and you can see this is the x-intercept, because that is the value of, actually this is the y-intercept. So it's this point right here. It's the point where the curve, the line, intersects the y-axis. That's called the y-intercept. So we know the y-intercept is 5, and likewise the x-intercept is where this line crosses the x-axis. The x-axis is where y equals 0. So the x-intercept is 5/2. So we kind of did that, and you can see that, you know, if I have these 2 points, I have enough information to draw a line. And then these extra ones are just kind of confirmation that I did everything correctly. So we have problem 13. Is that what we're going to start out at? Yeah, 13. So you get 3x plus 2y equals 12. And really all we're doing is we're setting up a table. Instead of 5 parts, there's only 3 parts to it compared to what we did before. So you got x, you got y, you have x equals 0 and y equals 0. So what you end up here is this, when x equals 0, you have the y-intercept. The thing you solve for here is the y-intercept, and the thing you solve for here is the x-intercept. So I'm just going to move these things over, and then actually it's going to make it too big here. Yeah. So that's kind of the way the table works out. So I'm just going to make another table, and then we'll just put it below it and fill it in with the actual numbers instead of just words. So you get x, you get y. If 0 is here, that gives you the y-intercept. So it's the easiest calculation because the first case, I take the original equation, I substitute in y equals 0. I don't really need a parenthesis there, so you know. So 3 times 0 is 0. So I can drop the 0. I can divide both sides by 2. I get y equals 6. So that's my corresponding y value here. And then you can do the second case where y equals 0. So I take 3. Again, I don't need the parentheses. So 3x plus y, but y is 0. So I get 2 times 0 is equal to 12. I get 3x is equal to 12. Divide both sides by 3. 3 over 3 is 1. 12 over 3 is 4. So the corresponding x value, which is the x-intercept, is 4. So I get 2 points. So what is it? How do you specify x and y intercepts? So given these coordinates, you can say the x-intercept is, okay, so that's when x equals 0, that gives you y-intercept. The x-intercept is for the y-intercept is 6. Or you can say the x-intercept is the point um, 4, 0, and the y-intercept is point 0, 6. Either one's acceptable. So if we add our thing like that, and so if we plot these points, we'll do the axes, and we'll have the x and y axis. This is 10. This is 10. This is negative 10. This is negative 10. So the x-intercept is 1, 2, 3, 4, 0. The y-intercept is 1, 2, 3, 4, 5, 6, 0, 6. So this is 4, 0. This is 0, 6. And then the line is this approximate line. So that's the function. You only need 2 points to be able to draw it. Okay, so where am I on this journey here? I think I'll just stop there for a moment. So we're going to stop at problem number 13. So let me stop it.